You're on.
Welcome to lab number 4 of CE371. This short video will provide an overview of the laboratory procedures. I encourage you to follow along on the written procedures provided to you in your laboratory manual. During this video, additional detail will be provided beyond the content in your laboratory manual. Remember, there will be a quiz regarding these procedures at the start of the lab period. Today's lab experiment is a permeability test. The lab procedures instructions outlined here will allow for the determination of the permeability of a clean sand sample by means of a constant head permeability test. During this lab test, special attention must be paid to the process of saturating the specimen in the permeameter, as this is the most difficult and potentially catastrophic part of the procedure. The first step in the process is to weigh the sand and the container provided. Your sand sample will be located in a container similar to this. We can weigh that sample in the container on the small scale. Step number 2 is to measure the inside diameter of the plexiglass cylinder. To do so, we're going to use the digital calipers. We want to make sure we're utilizing the proper side of the calipers to measure inside diameter. You want to make sure you're also recording this information in metric. All of our units today will be in metric units. And you want to measure this in 3 different locations and record that internal diameter of the sample for those 3 different locations around the cylinder. Ultimately, then, we'll use the average value of that diameter to be the average value of the diameter of the interior of the cylinder. Next, we want to take one of the rubber gaskets. There should be 2 of these gaskets at your station. And we're going to place the rubber gasket down in the groove at the bottom of the permeameter base. Then we want to place 1 stone on top of the base. We want to place 2 pieces of filter paper on top of that stone. And then place the second and final stone on top of that stack of filter paper. We then want to place the cylinder down on the base so it's resting on the rubber gasket. It should just fit around that stack of filter paper and stone. Now we want to use the caliper again, but in this case we're going to use this to measure the distance from the top of the plexiglass cylinder to the top of the stone. To do so, we want to extend the calipers using this end of the caliper to measure. What we're going to do is we're going to place the caliper in here such that the pointed end is resting just on the stone. You want to make sure it's physically resting on the stone and not on the space, the small space in between the stone and the edge of the plexiglass. Make sure it's resting on the stone. And we want to measure the distance down from the top of the plexiglass to the upper lip of the plexiglass down to the top of the stone. To measure, we're going to measure to the base of the caliper and then take our reading. Again, we want to do this in 3 different locations and take an average of those readings. That number is going to be the length of the sample or the height of the sample in our calculations. We now want to remove the cylinder. We're going to remove the top stone and the top filter paper and place those off to the side. We can replace the cylinder at this point, so the cylinder goes back down and sits on the rubber gasket. And inside the cylinder should be the single stone and the single filter paper. At this point, what we want to do is to make sure that we've got continuous pressure pushing down on the cylinder until we actually place the top of the permeameter and replace the wing nuts to hold the cylinder in place. This is where some teamwork with your team makes sense. Again, the intent here is to make sure that we've got downward pressure on the cylinder, so that when we add sand inside the cylinder, we don't end up with sand in between the cylinder and the rubber gasket, which would allow for a loss of water in the testing process. So make sure we've got continuous downward pressure. Doesn't need to be a lot, but it does need to be a positive pressure pushing downward on the cylinder. We're going to place sand into the cylinder. In doing so, we're going to place this in 3 separate lifts. We want our final top of the lift to be approximately 1.5 inches to 2 inches from the top of the cylinder down. That's going to save us enough room to place in the filter paper, the top stone, and a spring into the system before we close it up. So our third and final lift should be up here near within 1.5 to 2 inches of the top of the cylinder. When we place the sand inside the cylinder, it is critical that we not spill any sand on the workstation or onto the floor. In a moment here, we're going to record what is the new weight of the container with the sand. The delta between those 2 different measurements is going to be the weight of the sand we put inside the cylinder. If you wish, you can use the funnel to place your sand. Again, make sure you've got downward pressure on the cylinder, and that when you add the sand, we're not spilling any sand. All the sand we take out of the container, we want to make sure it ends up into the cylinder. So I'm looking to fill this up close to about 1/3 of the height of the cylinder. And when we're at roughly 1/3, make sure you bump off the funnel again, just to make sure that every grain of sand gets down into the cylinder. Each of the 3 lifts of sand is going to be compacted. To compact it, we're going to utilize the hammer provided. Now, this hammer, the height of the hammer drop and the weight of the hammer is not critical in this process the way it was critical for the modified and the standard Proctor test. We're simply going to drop the hammer from a height of 1 inch to 2 inches. Again, it's not a critical measurement. Roughly 25 drops per layer. Continually move the hammer around on the surface. And all this does is help compact the sand in there in an even manner. Bump off the hammer to make sure there's no sand grains that end up on the hammer. And then continue our process of filling the cylinder. This is our second of 3 individual lifts of sand. So we're going to fill this one up close to 2/3 full of the cylinder. Eventually here, having another hand would be helpful because your funnel reaches down in there and it's going to block the flow of the sand. Again, make sure in your process we're being very careful about not spilling any of the sand. Either stays in the container or ends up in the cylinder. We'll get close with this second lift. Okay, so we can consider that one to be our second lift. Again, 25 more drops with the hammer, continually moving the hammer around, just drop it 1 inch or so or just tap it lightly. Making sure that final surface is nice and flat. Make sure none of the sand grains are attached to the hammer. And then we can add in our third and final lift. It's possible instead of using a spoon, we can use a scoop, whatever it is we're utilizing, to make sure we end up with the sand down into the cylinder. Throughout this process, I'm continually maintaining some downward pressure on the plexiglass cylinder itself. and final lift. Just about the right height that I was looking for, 1.5 to 2 inches down from the top of the plexiglass cylinder. We're going to go around and tap that final surface 25 times with the hammer. Now we're going to weigh the container and the remaining sand back on a small scale. Again, the difference between the original weight and this new weight is going to allow us to determine how much weight of sand we place inside the cylinder. We now want to place, assuming we've got a nice smooth surface here, we want to place this filter paper on top of the sand. When you place it down in there, make sure you don't jam it in such that we end up with sand on top of the filter paper. We do want the filter paper to be on top of the sand. We're going to add the stone on top of the filter paper. Make sure it rests down in there. Again, maintaining downward pressure on the plexiglass cylinder. Now we want to determine the height of the sand layer. So again, we want to use the calipers, extending the caliper like we did before, measuring from the base of the caliper down to the top of the stone. Again, make sure you're not getting the pointed end of the caliper down in that small space between the stone and the outside edge of the plexiglass. Measure that at 3 different locations, down from the plexiglass to the top of the stone. The difference between this height and the original height we measured, again, is going to be what's the overall length of the sand sample, or height of that sample. Now we can place the spring on top of the stone, and then we're going to place the top down. Whoops. One item here. Make sure you get your second rubber gasket on top of the plexiglass, so that goes around the spring, and it's going to rest right on top of the plexiglass. Now we can add the top. So that should fit down and align with 3 different threaded rods. And in doing so, we want to make sure that we're placing it on there in a manner that it doesn't displace the rubber gasket. Continue to put some downward pressure onto the sample, onto the top, and then add our 3 wing nuts. We want to tighten those down evenly, just finger tight. We don't need to go to any great extent in tightening down those wing nuts. So add all 3 wing nuts. And then just make sure all 3 are evenly finger tight. And at this point, and only at this point, can we remove the downward pressure we were placing onto the plexiglass cylinder. Now the wing nuts are replacing that process. At this point, we're going to saturate the sample. So what you would do is you would take your entire apparatus from your workstation now, very carefully carrying it back to the sinks where I'm located at the moment, and I've actually got a sample already compacted and back here at the sinks and ready to go. So now that we're back at the sink with our permeameter and the sample inside the permeameter, what we want to do is we want to make sure it's set up so that we can allow ultimately the flow of water to go through the sample and discharge into the sink. So what we've got for this apparatus is we've got an upper funnel attached to this. We've got a yardstick or meter stick attached to the sample, to the permeameter, and we've got a couple of valves we can control. Now what we want to do is we want to initially saturate the sample before we test it. To saturate the sample, we're going to saturate from the bottom upwards. We do not want to saturate from the top down. We want to saturate from the bottom upwards. In doing so, that helps displace any air from the sample that might be currently trapped in the void space between the sand grains. Now, this is a part of the process that I mentioned at the start of the lab procedure that is particularly critical. It can be catastrophic to the process. If we don't do this in a particularly slow manner, we can create what's known as a quick condition, wherein the rate at which the water is pushing through the sample will actually displace the sand and lift the sand up. If that occurs, we actually have to go back, we have to clean out the permeameter and start over on the process. So I encourage you to do this process in a slow manner. What we're going to do is we're going to utilize these containers of water that are at an elevated position, and they have a PVC or plastic hose attached to them. What we want to do is you want to experiment with the control on this because they are a little bit temperamental. We want to experiment with the control and allow water to discharge directly from this container into the sink. So you adjust the control so we've got flow of water now coming out of this tube attached to that upper container. And what we want to do is we want to throttle that back so it's just a real small amount of water coming out of the container. It does have to have some positive flow. This one might still be just a little bit too quick. Small adjustments here. We'll slow it down so that we've got just a small amount of water dripping through the system at any given time. Again, doing this, ensuring this part of the process will make sure that we don't create a quick condition when we saturate the sample. Now I've got a reasonable flow of water coming through that hose. What I'm going to do is I'm going to attach it down here at the base of the permeameter. There should be a small connecting hose on there. If there's not, let us know and we'll get you one. But what that allows us to do is to simply slide the hose that's coming down from the reservoir of water directly onto the permeameter, and it will start to saturate the sample from the bottom upwards. To do so, we need to make sure this valve is open, which means the lever on the valve should be parallel to the direction of flow. Do not adjust the rate at which the water is leaving the reservoir at this point. But if we look very closely, we'll start to see water creeping upwards through the void space in this sand sample. We're physically saturating the sample. We're pushing air up and out through the system. The rate at which the water is climbing here is what I would consider to be the maximum rate that we want to saturate the sample. Meaning this will take some time to fill up. Be patient in this process because it's still faster to saturate the sample in an appropriate manner than it is to start over at this point in the test. So we're allowing that to saturate the sample upwards. Eventually we'll see water completely fill up this void space and then fill up the space above the stone. In time we'll see water come up through this upward hose and then start to fill up the reservoir. So the funnel is our upper reservoir for the permeameter. There is an overflow hose attached to the funnel at the top. Make sure that hose is located in a sink, because eventually we've got water coming out of the upper reservoir down through this hose, saturating the sample, moving upwards through the permeameter, through this hose, into the funnel, and we want it to be able to go somewhere. We want to continuously make sure there's water moving in here, allow it to overflow through this hose, and discharge into the sink. Again, hopefully you can see on the video the rate at which this is saturating. We want to take a look around, and you might see some air pockets, some pockets where we've got different coloration in the sand. We want to take the time to make sure all that airspace is pushed out of the sample. And we don't want to change the rate at which the water is flowing into the sample until we've actually got water overflowing out of the reservoir at the top, or the funnel at the top. Again, this will take somewhere in the neighborhood of 5 to 10 minutes, and we want to make sure that it continues on its own. What I'm going to do at this point is I'm going to transition over and show you a sample that is fully saturated and ready to go. So assuming you've gone through the process now, fully saturating your sample in that slow manner, what we've got is we've got water that has gone through, filled up the entire space, it's filled up this hose, and it's also filled up the reservoir. At which point, after that's allowed to run for a period of time, we can turn off the valve here at the base of the permeameter, turn it 90 degrees. We can remove the hose that was coming down from the reservoir, And we're going to take that hose now and we're going to place it up above at the funnel location. I recommend that you make sure your funnel is probably somewhere either in the upper third or bottom third of its distance of travel. In a minute we're going to move that funnel. We want to make sure we've got 3 different locations. So I either recommend you start low and move up high, or start high and move down low. But make sure it's located somewhere to begin with that allows you for some travel vertically. We want to take that hose now that was attached to the base of the permeameter, and we want to clip it to the side of the funnel. When you place the clip onto the hose, make sure you're not pinching the hose. We want to allow free flow of water, but what the clip allows us to do is simply place the hose there and leave it in place. At this point, we're now going to reopen the valve on the upper reservoir to allow water to flow down through this hose, and it's going to discharge into the funnel. What we want to do is we want to allow that continuous process of discharge in the funnel without opening this valve here at the bottom. The volume of water entering the funnel should be equal to the volume of water discharging from the overflow line coming from the funnel and discharging to the sink. So we may need to allow some time for that funnel to fill back up to this overflow line. We may need to adjust the rate at which the water is flowing through here. But just now, I've actually reached that overflow point, and I've got water coming out of the overflow line from the funnel and discharging into the sink. Allow that process to flow. Keep an eye on this to make sure the rate that the water is discharging into the funnel is not exceeding the rate at which the water can actually go through the discharge line. We don't want water overflowing the edge of the funnel. Allow this to run for a few minutes. And at this point, what we want to do is to measure the temperature in degrees Celsius at the center of the funnel. So you've got a thermometer at your station. Make sure it's on. Make sure it's set to the right temperature scale. And measure the temperature there at the center of the funnel as the water continuously flows. Then what we want to do is we want to measure the height of the water between the static level in the funnel and the discharge level here at the base. To do so, what we can adjust is the height of the meter stick. So we can adjust the meter stick upwards and downwards. We want to make sure that the base of the stick is located at the center of the discharge line. So the bottom of the stick should be at the center of the discharge line. And then once that is in place, make sure it's tightened down and that the stick's not going to move. We now want to measure from the bottom of the stick up to the static level of the water in the funnel. That is going to be the head height of the water moving through the sample. So the difference between the inlet and the outlet on the sample will be our first H1 associated with this test. So at this point, now that we've got water flowing in here at a constant rate, our overflow is working properly, what we can do is we can open up the bottom valve on the permeameter. In just mere moments, what we'll see is water will start to, in addition to going through the overflow, it'll also be coming out through the sample and discharging into the sink. Make sure we open that valve all the way. What we want to make sure is that the rate of water going into the funnel now from the upper reservoir is equal to the total volume of water coming out of here and the volume of water going through this overflow hose. We want to make sure it's equal. We want to make sure that the rate of water going in is not exceeding those two outlets, or otherwise we end up with water coming out of the funnel. But at the same time, we want to make sure that the water going in is able to keep up with the volume of water discharging from the two different discharge points, from the bottom of the permeameter and from the overflow line. What we don't want to see is we don't want to see a drop in the water level here in this sample. Make sure we've got enough water flowing through there. Make sure we're at a static condition. And you may need to play with the valve a little bit to make sure we can reach that point. So we've got a constant amount of water, or a consistent amount of water going through here. The amount of water going out of this discharge point and out of the overflow hose should be equal to the amount of water coming out of the reservoir and going into the funnel. When we've got that at a constant rate, now we can actually record the volume of water and the time it takes to collect a volume of water. You should have a graduated cylinder at your station. The intent is for you to capture a volume of water. The minimum volume of water we want to capture flowing out of the permeameter is 65 milliliters or cubic centimeters of water. That's the minimum. The expectation is you capture somewhere between 65 and 100 milliliters or cubic centimeters of water into the graduated cylinder. The exact number is recorded, but we don't have a target number to shoot for. Just record a number that ends up into the cylinder. So what we want to do is to have our stopwatch ready and our cylinder ready. This is typically a 2 to 3 person operation. When the first person places the cylinder under the discharge water here from the permeameter, you want to start the watch. You want to allow that continuous process to go until you think you're up to a minimum of 65 milliliters. One of the recommendations is simply place your thumb on the 65 milliliter mark, and then when you place the cylinder there, when you see the water is above your thumb but below the 100 milliliter mark, you say stop. You're going to remove the cylinder. The individual will stop the stopwatch as such. So we'll go like this. Make sure all the water coming out of that hose ends up into the cylinder for this period of time. It's now above my thumb. I'm going to remove that and stop the watch at the same time. Place the cylinder on a flat surface. We do not turn off the water here at any point. We just continuously allow this to flow. We're going to read the actual volume of water, the actual Q that ended up in the cylinder, and we're going to record the volume of water as well as the time it takes to collect that water as part of our data. After we're done with that process, we can dump the water from the graduated cylinder into the sink, dry out the cylinder, reset your stopwatch, and now what we want to do is we want to adjust the height of the funnel to a new location. We're going to slide that either upwards or downwards depending on where you started. Adjust it to a new location. In doing so, we may have changed the rate at which the volume can move through both the sample and the discharge. So we want to make sure that we allow this to reach equilibrium again. That is, the volume coming from the reservoir into the funnel should be equal to the volume discharging here as well as the volume added to the discharge from the overflow hose. Allow that to reach equilibrium again. Record your temperature at the center of the funnel a second time. Repeat the process of collecting a minimum of 65 milliliters of water, recording the time it takes to collect that volume of water. Read your actual volume of water, record the actual volume of water, and the time it took to collect that. Again, discharge this back, dry out the cylinder, move the funnel to a third height, recording each time now, just as we did with the first one, recording the height of the funnel at each location. So for a total of 3 tests, we're recording temperature of the water in the funnel, we're recording the volume of water collected in the cylinder, the time it took to collect that volume of water, and we're recording the distance from the discharge pipe here at 0 up to the equilibrium level of the water in the funnel to be our total head moving through the sample. At this point, you've got all the data you need to calculate the permeability for your sample. You want to actually record or calculate that permeability and record that information. Provide that information to your lab instructor before you leave. To confirm that those values are reasonable, I encourage you to look up a number associated with sand in your textbook and report that number relative to the number you've calculated to your instructor. There will be a table located on the blackboard. You need to populate that table with all your information before you leave. That will include your group number, your average sample height as recorded inside the plexiglass. You're also going to report the average sample diameter, the weight of the sand placed inside the plexiglass, the temperature, the heights, the volume of water collected, and the time collected for all three tests on the blackboard. Before departing the lab, ensure that your workstations have been completely cleaned up. Sweep up the floor around your workstation. Show your data sheets to your instructors, and then check in with your instructor one final time before departing. That is the permeability test and test number 4 for CE371. Okay.